So I think in the last session we primarily were looking at comparison of AWS versus Azure. So I think just a quick roundup. So we discussed on the accounts how it is different between AWS and Azure. So Azure has subscriptions account, and under that there will be multiple subscriptions, and under each subscription there will be a lot of resources. Unlike in AWS, it's all just account only, account and under that resources only. There's no concept of subscription in the AWS side. Then we also saw about the compute, where we saw virtual servers, the comparison, virtual machines, batch, virtual machine scale sets for scaling purposes. Uh, and VMware infrastructure, then you can use VMware by Cloud Simple, Cycle Cloud for HPC requirements, high performance compute, and container world. So you have container instances, container registry for hosting all the containers. Then Kubernetes equivalent is AKS. Then VMware, again VMware by Cloud Simple, and for sort of for mesh purposes, it is Service Fabric Mesh. And on serverless side, it is functions, which is equal to lambdas on the AWS side. Then we saw about the databases. So RDS is on the AWS equivalent, but here on the Azure side it is SQL. We have separate databases: SQL database, MySQL, Postgre, on the relation structure, um, and NoSQL. NoSQL, it is all Cosmos DB what is being promoted. On AWS side it is all independent, but earlier. Azure wanted to have separate DBs on the NoSQL, but later they decided it is a multi NoSQL DB. So that is a concept that they're going towards. So if you in the same Cosmos DB, you can store all JSON based or column wide based or key value pair based NoSQL. So all these things are or graph DBs. So all these things are possible in one single DB. So yeah, so all the NoSQL is completely all the investments are going on Cosmos DB, no separate structures like in AWS. So multi all-in-one database kind of a thing. Uh, and the caching side, cache for Redis. The database migration side, it is more about the migration utility, things migration of your on-premise database, on-premise data to cloud, or multi-cloud. I mean, sorry, like homogeneous and heterogeneous genius way of transferring the data, where you want to transfer the data, database data from on-premise to cloud, or within the cloud. Let's say you're already using one database, you can use another database. You can also use migration service. So that is on the database side. I think we have covered all these things in last session. So I'm just quickly moving. Messaging. Yeah, this is more about the queuing. So between two systems, system A, system B, you want both systems to work asynchronously. The keyword is asynchronously. So system A will push the data to messaging, and it will continue further, and system B will take it from messaging and process it. So that way system A, system B are independent. It's like a WhatsApp, right? I mean, asynchronous communication. The person A will send a message to WhatsApp and he will continue with his work. Person B on the other side, whenever he's free, he'll check the message in WhatsApp and respond. So similar concept. So both are asynchronous. So in that category, so you have this the queues. So primarily, so the queue storage, service bus, and event grid. So primarily, the purpose is, I mean, queue storage and service bus more or less conceptually same, but just that service bus has additional features which can integrate with other AWS, other Azure products. It has integration with many other Azure products, like it has connectors and other things. But you don't want connectors and all. You just want plain simple queuing service. Then yeah, queue storage is a solution. But otherwise, both of them more or less does the same. Just that more bells and whistles added to service bus. But yeah, so these are all for queuing purposes. But this other way is like notification. So notification, yeah. So you want to notify someone when some action or event is triggered. So then you use event grid. For example, where is a notification, system A completed some action, and that pushed an event. So there's on the other side there's a consumer system B who is waiting for this event to and to take some action. So we're talking about an event there, and that event can be stored, and also you can subscribe to that event and other things. So typical to the Kafka worlds and open source or the Pulsar worlds. So that is the equivalent to that in the this event grid. I think this is what we covered so for the last session. I think let's go in deep in today's session covering this web application. I think this is more about the PaaS model for especially if you want to deploy a web application. So what options we have. So I think we app service is something where we get a runtime inbuilt. So you just need to bring your binary. That's all. So and you can deploy your web application into AWS or into Azure using app service. So the typical scenario is either you can bring a container based or you can bring a binary based. For example, a .NET or a Java based application. So in Java world, you will take a jar file. So you can take jar file and deploy it into app service, or you can bring a containerized equivalent of jar. So then you can deploy the container also into the app service. So basically, it supports both container and non-container scenarios. Um, and then the advantage is that you get the runtime. So you just need to bring your jar. You don't need to bring uh, any of your runtimes. So runtimes are all managed inside by app service. Like for example, for running a Java application, you need a JVM and other things. So those are all already there and managed by Azure. So that is app service. And let's say now under web application, you will also have a lot of APIs. At some point, your application will grow big and you have to manage a lot of APIs. And managing APIs is not an easy task, especially when the APIs are growing. So yeah, to manage that, you need some tools. So that is one is API management is one such tool. The equivalent is API gateway on the other side. And content delivery network is more about storing the images, especially when you want to do the images and HTML static files. You want to store it. After is more about dynamic side. But if you want to store static images or static website or static images which don't change or videos which don't change, then you can put all those assets under content delivery network. Is equivalent to that is CloudFront on the AWS side. So you'll put it here, and so that way it is cached, and it has a lot of advantages in terms of having the caching facility, so that the videos or images which are static, so it will be loaded faster, and yeah, based on wherever you are in the world, you get a better performance when especially downloading the data from CDN. So so it's more about storing this. It's a repository of all the static content in your architecture. So so that is content delivery network. I mean, yeah, I know all this terminologies. I think we are looking at the breadth of it, so we're not going into the depth. I think that will take in the next session. So just get familiarized with on the product names. So that is the primary purpose of this session. I'm going a bit fast, but try to just be familiar with the names and what it is used for at a high level. So yeah. Um, right, and then next is front door. Front door on Azure side is primarily for especially when your data it is like a Route 53 equivalent or global accelerator where your data is spread across different geographies. I'm talking about not I'm talking about regions or geographies across geographies. Then managing, let's say you have two instances, one in India, Azure data center, and other one in US, maybe other one in Europe. So to manage, and we want to route the traffic to all these three different geographies. So in that case, you need a global level network management system. So not at a data center level, but we're talking about at a region level. So that is what this front door. So it intelligently matches from where the traffic is coming for a given request. So, for example, if the traffic is coming from Brazil, for example, so the nearest center is US. So not for example Europe or Asia Pacific. So in that case, so that is what it intelligently identifies and routes the traffic accordingly. So that is the area that this front door plays a role. Right, and then uh, so and it is just a comparison purposes. App service is there's a product in AWS called Lightsail, which does it will not it will help your deployments make easier in the AWS side, where you can deploy your application which you need to give so many inputs. For example, if you create a virtual machine, you have to give so many inputs in the virtual machine. But let's say you're looking for a simple solution where you're as many defaults as possible, but just quickly deploy my application. So if you're looking for a such simple solution, primarily for a developer, where he need to bother about many things, about the networking or about the configuration, or about the compute, or about the database, or so you don't need to know much about it, or he's not having much knowledge on it. So you just want to deploy his application just like that. So then Lightsail is a product in AWS which make many defaults for you so that you can deploy your application very quickly. So yeah, so that is very specific apart from Elastic Beanstalk. Uh, but yeah, for here in the Azure side, it's both are same. I mean, both app service does both things. You have both options here. So yeah, that's on the web application side. So to summary, you want to deploy something, app service. You want to manage your APIs, API management for managing your static content, content delivery, and for global networking, then front door. Moving to the specific networking. This is one of the very important topic for for the exam, and also for in general for you to know. So uh, so far everything is on cloud, is on publicly accessible or internet. But let's say you have specific requirements where you want to have your own boundary of restricted data, or you want to have your own mimic of a data center in cloud, where others can't access your network, or because it's a tenant-based system. So cloud is a tenant-based system, but you want to have your own data center requirements, or your own boundary of networks. So then networking plays a major role in the cloud area. So, so in that space, the parent of all the networking products is virtual network in the Azure world. So AWS is VPC. So I think we covered enough on the VPC in the AWS side. So when I was reading this virtual network, I found more or less everything is same. Typically, you have all the concepts. I mean, the general networking concepts. You have you can create a virtual network with a IP range. Then you'll have a private subnets. So under a VPC. So same here. Virtual network. You create a virtual network which is like a broader IP range. Under that, you can create a subnets. So with a again, the subnets will come under private subnet and public subnet. So yeah, so all those concepts exactly mimic here. So that's about VPC, or the virtual network on the Azure side. And yeah, So let's say once you created a virtual network, then then there's a requirement where you want to transfer your data from your on-premise to cloud. Um, and so in that case, on-premise and cloud requirements. So there will be some networking requirements for on-premise and cloud to talk to each other, right? So that so there the VPN plays a major role. So the VPN gateway is primarily meant for that. The name is same on both sides. So that's about VPN. I think we use at least some of you guys definitely would have used VPN. So it's where with VPN you will connect to your data center in your on-premise world. But here you'll in the cloud world you'll connect to a virtual network. So which is also similar to a data center on cloud. So so others can't access. I mean, without VPN, you can't access to this network boundary. Similar concept. And yeah, so that's about the VPN. And then if you go further on the global networking side of it, it is these are all within your network boundary and within your boundary. Or for example, within your region. But let's say if you have a broader set of regions or multiple regions, then traffic manager is another thing which plays a role of a Route 53 equivalent on the Azure side. But if you remember, the Route 53 does two things. One is the global traffic management, and apart from that, it also gives a DNS facility also. DNS is like domain naming system. Buying a domain like google.com is just a domain, right? So you can similarly you can buy avc.com as a domain. So you can buy domains also from Route 53. I don't know. People call Route 53 Route 53. It's yeah, but then it's all same. Um, but yeah, you can buy a domain name also. So, but here on the Azure side, DNS is meant just for domain management. But yeah, and like buying a domain is I like this idea because it is logically both are different concepts. So like buying a domain is one, which is a unique feature. But yeah, like managing the traffic is another category. So yeah, that way it is logically separated here in this Azure world. So yeah, so but in this world it's all both same. Yeah. So yeah, then once you manage the traffic, so traffic manager is meant to manage the traffic based on a lot of parameters configuration. Like if you remember the Route 53, you can give a lot of weightages based on weight or based on geography, based on like which node you want to send the traffic to. So based on the networking and other parameters. So based on health, so a lot of things you can configure. So based on that, the traffic will be routed accordingly. So yeah, similarly, you can do the same all these configurations in Traffic Manager also. So you can route the traffic based on some conditions. So we have various conditions that you can configure. So accordingly, based on the rules configured for the traffic, yeah, it will do the routing accordingly. That's the purpose of Traffic Manager. Right, and then next is direct connect versus express route. So this is so far all these are all on public internet. For example, this DNS domain name require a public internet, and traffic manager also requires public internet. Let's say you don't want a public internet. You want a private data transfer, private network. So for safety purposes and other things. So if you are looking for a private network data transfer between on-premise and cloud. So then in the AWS world, you have direct connect. So similar to that in the Azure side is express route. So so express route is primarily meant for yeah, the private data transfer between on-premise to cloud. So no one can hack in between, and so it's all on public private network. Right. And then next is the networking side. We also have load balancers. Again, generally the load balancer are classified into two types. One is a network load balancer and application load balancer. So network load balancers or the load balancer on the Azure side. So this all work on the concept of UDP and TCP, not HTTP. I mean, if you remember the layers of networking, the layers of the transports, right? So layer 4 is meant for that. So layer 4 is at a networking level, primarily relying on TCP or UDP based protocols. Uh, but yeah, this one is more familiar for us. Like this is HTTP or HTTPS, like HTTP based protocol based transfers, and you want to manage the load based on HTTP or HTTPS. So you use application load balancer, or on the Azure world, it is application gateway. So that's the difference between these two. So load balancer is meant for UDP versus TCP, and application gateway is for yeah, the HTTP and HTTPS. So in real world, yeah, primarily use more of application gateway because most of the traffic is HTTP based or HTTPS based. But imagine there you are a situation where you get loads and loads of yeah, of the queries, or the hits that you get on application. Then HTTP is generally slow compared to TCP or UDP, because it has to manage, it has to send the data packets over the network, and generally on public internet will be slow and depends on other factors. So in that case, load balancer will be your best bet. So if your traffic is very high, then always prefer load balancer compared to the application gateway. Right. So that's on the networking. To summarize, virtual networking is primarily for managing your data centers on cloud with public and private networking aspects, and we yeah, on-premise. And once you want to connect to your cloud uh, data center, then you need to have VPN from your on-premise. So that's what this VPN gateway. And yeah, and you want to buy domain, manage domains. Then yeah, DNS manage. When you say domain, it is like some google.com, or any other some domain that you want to purchase and want to register your for your website. So that is DNS. Again, this is managing multi. I mean, domain. Once you bought the domain, so that domain should be mapped to various routes. One in, let's say you have one website, and you have instances of your services running in different geographies. So let's say assume there is a virtual machine in US, virtual machine in Europe, and virtual machine in India. So based on the traffic that you hit on the DNS, based on whichever VM is free, you want to route the traffic. So then traffic manager will help you there, and you can do a lot of settings here for the rules. You can configure a lot of rules. Based on that, it will transfer the traffic accordingly. Then Express route is primarily for on-premise on-premise and cloud, where you want to transfer data privately, not public. So others are this is public, but this is private network. So, then yeah, we saw discuss about the load balancers, network based and application based. Any questions here? Okay, I'm moving further.
Yeah.
Storage. So this is a very important section for and yeah, we use a lot of storage, right? So you have various options here in the storage layer. I mean, it's same in both AWS and Azure. So it starts the options that you have are you have to decide which storage type of storage you need, and based on that you select a specific product. So if you come to object storage, where you all your even text and blob, everything is a object, a blob or a glob. So that for that purpose, object storage plays a major role. Um, on the AWS side, it is S3, simple storage service. On the Azure side, it's blob storage. Um, and if you want server disk-based storage, so we're talking about your laptop where you'll have a hard disk, right? So if you're looking for hard disk based storage, the hard disk again there are two types, right? Solid state drive and HDD. So you have both options here, so SSD and HDD. So based on that, you can select either. I mean, this is one option, not many options. Managed disks is a product on the Azure side, and EBS is equivalent on the AWS side. And let's say you're looking for a file-based storage, where it's file-based storage works on a protocol called SMB. SMB. So if you're looking for a file-based storage, then options are EFS, Elastic File System. In Azure, it is files, just files, Azure files. So it's on the file storage based. And let's assume we're talking about these are all on cloud, right? These are all options that you get in cloud. But there'll be requirement of a hybrid storage where you want to transfer the data between on-premise data center and cloud. So then we're talking about hybrid strategy here. When I say hybrid, it is on-premise and cloud. So you want to have a common storage in on-premise. Once you put the data into that, it will automatically sync behind the scenes to the cloud. So for that, that's called hybrid scenario. For the hybrid scenario, yeah, the solutions are storage gateway on the AWS side and store simple on the Azure side. So and also the primary thing is that the storage gateway is or store simple primarily does you have to set up um, uh, a software where you will it will act like your another drive, so C drive, likewise it'll like external mount that you need to attach, and once you push the data to it, it will automatically sync the data to the cloud. So that is what this store simple is. Behind the scene, it will primarily the blob storage for this. But if you're looking for a file storage, which is this, then you'll use file sync. So so that is a difference between this. On both sides, the data sync on the AWS side and file sync on the Azure side. So these things will be there on your premise. So it will be like in your network, your company network. It will be there. So once you copy it behind the scenes, it will do the sync of the data to the cloud. So again, you can do it over public internet, or you can do it on a private network. Again, this networking aspect will come there. So if you want to do it on a public internet, it anyway by default is public internet, so you can transfer it. But let's say you want to transfer data over private network, either you can use the express route, or you can create a VPN and you can push the data over to your network. Then next is on the let's say you have all the data stored, but you want so some of the data may not be very relevant to you, but yeah, you need it just for audit purposes. You want to store it. At the time, you don't want to use the on-demand storages, because on-demand storages will come with a cost, right? But let's say you have a requirement where you want the data, but maybe not very frequently you'll access it. So, for example, archival category or a backup category. So you will need it, but you will not use it daily. You'll need it maybe once in 10 days, or maybe once in a month, or maybe once in 6 months. So uh, based on the requirements, you can use the uh, the archiving or backup category of storages. So storage cool tire. So in the storage in the Azure side, we have two things. When you select, I will show you to when in the screens, when you create a storage, it will ask you to select either a hot tire or a cold tire or cool tires. So when you say hot tire, you're talking about on-demand storages, these are the on-demand storages. Cool tire is like you don't need them, but if you want, you'll get it. But it will take some time to get or download the data from these storage units. So for such category, so you have storage cool tire is a solution, and On AWS is all S3, so S3 infrequent access. So that is a equivalent program on the AWS side. And the next one is archive and storage archive access tier. Primarily, if you want even further, like you need it only once in a year, or once in 2 years, you need that data. So otherwise you don't need to have this data on daily basis. So then this is more archived structure compared to the cool tier. So then you use storage archive access tier. So which is like it will take at least to, let's say if you need it, it will take some time for you to download, but you will get it. It will take at least some hours to get the data to your premise again, but you will get it. But the cost is the advantage is that you'll get the storage for a very cheap price compared to all these things, because all these are all on demand. You get it immediately. But here this will take some time and you need it. So yeah, for such requirements, primarily archiving or backup category requirements, you use these tools. Um, so on the equivalent on AWS side is S3 Glacier and Deep Archive. Right? Right? And then last one is backup. So you can use tools like these are all primarily backup tool where you can. They also come under the backup category, so you can take a backup of the files. So then you need Azure backup, same name here on the AWS side. And let's say a requirement of bulk data transfer. Here, especially we are talking about the storage again, but here you want to transfer the data from your on-premise to cloud. So that's why it's called bulk data transfer. Let's say your company decided to move everything to cloud. Uh, so first thing is you have to transfer your on-premise data to cloud, right? So for that, what options you have? So one is if the data is not very huge in petabytes level. I mean, it's not just in gigabytes level. Then you can use import and export. Like you can import using this import export. You can um, take a backup of. We can import your on-premise data to import export tool. So the advantage is that it will be more faster compared to any other storage options here. So it will have better bandwidth, and so it will be more faster. So yeah, so using this import export tool, you can import, and then once you take it to your cloud, then you can export it to other products within AWS. So it's primarily import export tool is meant for that. But this all is on internet. Right? Like internet is generally slow. Let's say you're a big data warehouse based application. Your system, your company is a big data warehouse, and you have huge petabytes of data, and that you want to transfer. And transferring such petabytes of data over the internet is definitely takes a lot of time. So in that case, cloud provides like a box kind of a thing, where I mean it is nothing but data box or a snowball category. Snowball family is primarily it is like a CPU. If you remember that olden days, the CPU box, right? The CPU box, the rectangle box. So similar to that, you'll get a CPU of a setup. So you get a physical data box to your on-premise. Then you will transfer the data to that box or a snowball equivalent, and then you ship that box to cloud, and the cloud they will transfer from the physical box to the cloud. So that is physical data movement on a hardware. So that is what is this bulk this data box or snowball family here, right? So that's about the storage aspect. I mean, yeah, I know it is too much of content to take in, but just be familiar with the terminologies and categorization. I think that is the primary purpose of this session. Any questions here? Okay, I'm moving on. Then comes the big data and analytics category. Uh, I think in the last session, someone is asking about where is a big data, the database category. Yeah, so big data has a set of tools which are which are different and they're classified under the big data and analytics category. Uh, Data warehouse. So that is, I mean, yeah, database is different. Data warehouse is different, right? So it's for data warehouse requirements. The AWS popular tool is Redshift. Here it's called Synapse Analytics. So Synapse Analytics is having set integrations to all the popular files, I mean, all the file systems that we saw, the storage aspects. It has integrations to Blob, Manage, Disk, all the file storage. So it has it can read data from all the storage aspects and also from external world as well. So it can take it has various sources from which it can take data and it can process it and do some analytics on top of that. So that is what is Synapse Analytics is. Then on the similar category, you have the data lake aspect, right? So which is getting popular these days. So yeah, so you have structured data, semi-structured data, unstructured data. So you can pull all this information and form a lake. And from the lake, you can use the the processing tools like Synapse Analytics or you have big data processing units like HD Insights and other things. So you can use. So, but first the requirement is you need to pull all the data, then you can process it. So for pooling all the data as a lake, so that's called as data lake. That's a general terminology, but yeah, in the AWS world, it is lake formation, and here in the Azure world, it is data share. So so yeah, it is like you get data from multiple sources and put it in one place. So from here you'll it's all collection, data collection. Now from the collection unit, you take this data and process it. So yeah, so it's more about collection agent of data. And again, once you have the data collected, either you can use for simple requirements, you can use Synapse Analytics, of typical ETL functionality. You use that. But let's say you are looking for not just ETL, but you have advanced requirements or to process millions and millions of data. Then ETL will not help you. I mean, this is the ETL category. But in the if you are looking for an advanced requirements, then ETL may not be suiting your needs. Then you need something more bigger than that, and that is what this Databricks or the big data processing tools will help. So for big data processing, primarily when someone talks about big data processing, there are two things, right? I mean, the uh, primarily the Apache side Hadoop concept. The Hadoop is more popular for the big data processing, which came some less than 10 years before. Uh, but of course, the Hadoop concept is extended further uh, because it has its own drawbacks. Then extension of Hadoop concept is Spark, so Apache Spark. So yeah, so this that is the categorization. Like if you're looking for Hadoop based implementation, then HD Insight is your tool for pure Hadoop based big data processing. But if you're looking for more advanced than Hadoop, then primarily you're talking about Apache Spark, which is even better, has a lot of advantages compared to the Hadoop framework. So then use Databricks. So yeah, so one-liner HD Insight is for supporting Hadoop, and Databricks is Spark,
So,
Apache Spark.
so Sham,
Yeah,
so when you talk about big data, right? So Hadoop is itself and its own infrastructure, right? Like it is like a rack and
yeah.
many machines in there. So are you saying like with Amazon and Azure, right? That hardware is no more required. It's going to be like it's just going
No,
to
it
be.
is
No, that is required. I
no,
mean,
it is.
infra.
It's all managed service, man.
Yeah,
Mhm.
correct. So you
No,
have
no.
to
See,
you
you
have to form the
understand.
cluster. You
Yeah,
need to form the nodes, master, slave, all those things you need to provide. But yeah, it's all just the inputs behind the scenes. All these cloud vendors will do the magic of managing this behind the scenes. Yeah.
yeah. So there is a subtle distinction between that, right? Like, so when I say Hadoop hardware, right, because the data means when you carry data over network, it is always slow. So to kind of control that, what they do is they build custom infrastructure. Basically, they kind of raise up a rack, and they have their all the cluster machines sit on that same rack. So there is no need for sending out data on the network and getting it back. So it is all within when you do a network cluster,
Yeah.
actually, that's how it is actually.
Correct. Correct.
So I'm just kind of asking a kind of cynical question, like how um, cloud can do that actually behind the scenes. It
Yeah.
cannot, like it can form clusters, but it's not going to be
Yeah.
as
Yeah.
efficient as the hardware. Yeah.
Yeah.
You
Correct.
answered your own question, right?
No,
You,
I'm not.
you
I'm not answering. I'm
no, no,
asking like
no,
yeah, yeah.
no. No, what I mean is, see, for example, what is cloud? Cloud is like everybody is paying the data center, right? So it's a multi-tenant data center, and whatever the individual, like you said, right, whatever the hardware specific accelerators, network specific accelerators, storage specific accelerators required for that specific managed services, it's all being taken care within that data center of the EMR, for example, right? In basically all these guys, right, what they do is they just try to learn the hosting the Hadoop or Spark and see all the what are the problems being faced. Then how to give the maximum hardware and infrastructure along with the network and storage so that it could be managed as a managed service so that end users, for example, in PG&E, right, we have a huge big data shop. Okay, so these inspectors, right, these California inspectors, they take the images, pictures, and those pictures will be analyzed, and they actually try to repair the whatever the electric things being malfunctioned. See, there's a huge problem. The fire in San Francisco, you see that fire problem, right? There is every summer it comes, and it actually has lots of legality, and they have obligation to not to spread it. They have to do yeah whatever it takes to subsidize that fire. So one of the ways to do that is they are getting so many data from the sensor. The sensors are basically coming from the those drones, right? Those self-managed drones. They take the picture because it has you have to go in the elevation, and you have to go even if it is a fire happening, you should know the different angles and so on. And all the data is coming to a data lake, and we are using EMR for that, and it is scaling pretty well. So this is a live example, right? So that's why I'm sharing it to you. uh, they are using both the machine learning. Basically, machine learning is used to say that, okay, given a picture, it will tell you whether this picture has a this particular, they call it as a corona problem. This is not a, this kind of what we have as a corona. In their language, corona means it is some specific form of copper deposit or something like that. So how do you, given a picture, it can tell you is there is a corona layer deposited in some of those places, so that they have to do the corrective action. Otherwise, there will be a problem of the wire getting broken down, and that will create a wildfire again, right? So the story is, at the end of the day, it's being exploding into so many layers of data comes, videos and audio and pictures, and all these are doing it very well. I was surprised actually, like you said, before joining PG&E, I didn't have too much of exposure on any of these things. But these guys, right, they actually invest heavily on the infrastructure so that the managed services scales up very well. That you cannot expect from even like companies like us. that is where all these new technologies, it's going to scale up more and more towards cloud, because it cannot be possible to maintain on individual company basis anymore. But it is working. Make sense?
Yeah, that's all. Yeah, no. So see, this is all on the user side, right? And what I was trying to
No,
get
but to
at
get
is
the
this.
user side, you need to have the infra side, right?
No, no, that's
How
exactly
can
what
you get
I'm
a good?
trying to come at. No, no, wait.
Yeah,
What I'm
yeah.
asking is, like, cloud
Uh,
means you don't have visibility of where the server is sitting or where the compute process is sitting, right? In
yeah,
Hadoop, it's the opposite of that.
Yeah,
You got to know exactly where the server is sitting,
yeah,
and the cluster has to be in a very close proximity.
yeah,
What I'm asking is, do the cloud providers kind of provide that kind of a service,
yeah, yeah.
special service for
Correct.
big data and analytics?
Yeah, yeah. I think your answer for that is placement strategies. Okay. So cloud providers they provide the placement strategies wherein you can decide when you're creating a cluster, you can decide where your node should be. Our node is like a virtual machine equivalent. So where your node should be available. So when this is another very important exam question where for your requirements where you're talking about the big data kind of requirements. Your placement strategy should be local, meaning when I say local within the availability within the availability zones. Because if the node is across availability zone, then there comes the problem of data transfer and latency might be applicable. So basically, when you select create a cluster and create a nodes, so you select a local setup. When I say local, everything is in within one availability zone itself rather than selecting across availability zones. Yeah, I mean, yeah. So the answer is that. So maybe I think they answer your question.
Yeah, that's
yeah.
exactly what I
Yeah,
was trying to get at. Yeah,
yeah,
okay,
exactly.
thank
Through
you.
Yeah,
managed services, they take care of it. See, you don't know it, but they take care of it. That's what I meant. See, when you create a cluster, you're not trying to say this is your placement group. You want to put it together. You don't have any control, but they take care of all.
Yeah, got it. Yeah.
yeah. Okay, so as per this placement strategies, you can decide, yeah, where your cluster or the nodes within the cluster should locate. So and yeah, again, so just coming back to this topic, so it is on the AWS side, EMR provides both Hadoop and Spark. Both are supported in the same product, which is EMR. But on the Azure side, they separated this. And then yeah, this then comes as data lake storage. Again, to process something either by Spark or Hadoop, first the data has to be stored somewhere. So that is data lake storage. So EMR is like it is having its own inbuilt storage as well. Again, internally it uses the other storage platforms. Um, but yeah, here we have a separate product for that category. Right, and then coming to the ETL side of it, so primarily the ETL data pipeline or glue. These are the popular ETL categories. Here it is data factory. Data catalog is also used, but I think more it is all like data factory has more advantages and is being promoted very heavily for the ETL requirements compared to catalog. But yeah, but primarily both comes under similar category. So it's more about how will you organize your data pipeline for your ETL requirements. So that is what these products are. And data factory has integration with all the popular all the storage within Azure and outside Azure as well. I mean, it has integrations to even Google Cloud and AWS storage, S3 storage, and all. It has integrations to all the popular within and outside Azure. So it has integrations to that. Again, again on the DynamoDB is more at the database level category, but but it is also one of the popular ETL tools. That's why it is coming here. So for the ETL, you generally you'll generally want to store something. You look for a cheaper storage solution for temporary storage purposes. So in that category, NoSQL would be a best fit for the CTL temporary storage requirements. So there you use on the AWS side you use DynamoDB, and here use table storage or Cosmos DB. Again, table storage is one of the storage options, but I think again, as I said, like Cosmos DB is now kind of promoted heavily, and at some point maybe table storage will be phased away. But yeah, Cosmos DB is one single solution for any NoSQL requirements in the Azure side. Then coming to the analytics aspect, so once you have processed all the data either through big data or ETL pipelines, you process the data. Now it's time for visualization, so and analytics. Then in that case, you have stream analytics, data lake analytics, and data lake store. It is not just one product. For they categorized it based on how you get the data. Either I mean the data can be again it can come as in the form of a stream in the big data pipeline, right? So data can come in the form of a stream, or it could be it is not a stream, then it is like a is a physical object lying in your some data like storage. Then so then in that case, so the classification, yeah, so you have to use data lake analytics, and of course you need also data store also required. Once the data is there in data lake store, you will apply the analytics on top of it. That's why these two products are there. So, but if the data is not a cold data, but it's real time streaming, then and in real time you want to form analytics, then stream analytics is your solution. But on the AWS side, it is all Kinesis. Kinesis is your single analytics platform, which can do both in one product itself. Right. Again, on the visualization aspect, Power BI, I think it's a more popular tool in this space of analytics. Um, so on the equivalent on the AWS is QuickSight, uh, and uh, and now you have data. I mean, you can do all fancy graphs in various formats, in both real time and also in the cold storage aspect. So both hot and cold, you can do everything in Power BI. Um, and then yeah, it has. I mean, many people would have used it in on-premise as a licensed product, but now the same product is also available in cloud. So you can bring your existing licenses on your on-premise Power BI to cloud also. So um, and then next is cognitive search. So this is more about the search facility. So it gives a lot of, I mean, you can do it in multiple ways. So the search of data on cloud. So the data can be in any storage layer, but with it should be possible to search the data where it is. So that's where this cloud search or cognitive search will help you there. And I think someone was asking question in the last session about Athena. So yeah, I think this comes under the category of search again, where Athena is primarily meant. Let's say it's a SQL based query tool where you can write. Let's assume the underlying storage is S3, like data storage platform here, assuming the data is in S3. So S3 is nothing but a folder-based storage or a blob storage equivalent. So let's say once the data is all there in your storage in folders, and in that there are files, uh, and assume there are a lot of folders and a lot of files, and don't know where your file is located. So in that case, you can do let's assume you are giving you have an option to write an SQL query for it, where internally it searches all your folders and get the data for you. Similar like select star from with some where conditions. So that is what is Athena is. So you can do a search on a storage, primarily object storage. But this scope is restricted to S3 only, so that's what I'm telling. It's object storage. Same applies here, where you have a data lake and you have data is available in the data lake. Then if you want to select or search something, you can use filters in the data lake analytics, and you can get the data. So that's about the big data side of it. Any questions here?
So Sham, it's almost our mark, right? So do you have anything else coming next?
Yes.
Otherwise, yeah. What is the next
Yeah, we have a
slide
few
you have?
more on the regions, DevOps management, mobile.
Okay.
Yeah,
Yeah.
there's a few more topics are there. Today, I think it will take. I think we can, if logically, we can break here the video and then take some questions and then
Yeah.
we
Just
continue.
break the video. Let's have a discussion here. So, guys.